Hi, this is Joe Bruno, your instructor for Math for the Inquiring Mind, and I just am making this brief video to help explain one part of Module 6, and that is part of graphing functions. This question is very illustrative of how to graph a function, and this question might illustrate a function that you're not used to since being in school. And also, even when you were in school, many of the functions you graphed were not as realistic as this one. So this is not even a question, really. It's just a description of a type of graph. It says, basically, we have a function for gas mileage for a car. Okay, let's see. We need an explanation. This says y equals negative 0.0077. That's a really small number, right? That's less than 1%. Negative 0.0077 x plus 45.556. So y equals some little tiny number subtracted from 45.556. I know that it says plus, but it's a negative number we're adding to 45.556. So what's going on here? This function tells a story, but I don't know what the story is until I read more. So I'm going to go back to the previous sentence. Although this is not an exact relationship, I'll highlight what I'm reading. Although this is not an exact relationship, there is a linear equation that best describes the relationship between those parameters. Oops, let's go back a little bit more. What is the relationship between the weight of a car and its mileage? Here we go. Relationship between the weight of a car and its mileage. This is a typo, by the way. I didn't write this up. It's a small typo. It should say gas mileage, I'm sure, is what that means. So the relationship between the weight of a car and its gas mileage. All right, that helps us. That means those are going to be the two variables in this equation. So which one is weight and which one is gas mileage? Well, the car weight is the given. Okay, the car weight are the x values down here. So the car weight is x. Okay, that's what's on the x-axis in the graph, and that's what clued me into the fact that the car weight is here. Also, we normally try to figure out miles per gallon. I'm sorry. Yeah, gas mileage, miles per gallon on the highway. That's what we're normally trying to figure out. So that's what makes it the dependent variable. That's what makes it the y values over here. So we use the weight of the car. That's given. You can just weigh it and find it out. You don't need to do any math to figure that out. You can just weigh the car, and there's the weight of it. And plug it into this formula, this little number times the weight, plus some weird number, 45.556, is going to equal the gas mileage. Crazy. I know. Let's see if it makes any sense. So let's look back at our graph and see that we don't have to figure anything out. Whoever made this graph, or whatever program made this graph, already figured everything out. But let's mess around a little bit to figure out what this equation is talking about. I'm going to use Excel to help me, okay? That's from a different question. Okay, I'm going to open up Excel. No problem. The reason I'm not just using Excel because we use Excel in this class. I'm using Excel because it will make this question a lot easier to discuss. So we have weight, and then we have gas mileage. Okay, the weights of cars are just given. We're just going to put numbers in. I think they give us numbers like, let's take a look. 2,000 pounds, 2,500 pounds, 3,000 pounds, and everything in between. Okay, so those are car weights. Let me write those in. I'm going to put 2,000. Sure, I'll put 2,500. I'll put 3,000 and 3,500. Okay, we could do anything in between or all around. I'm just going to use those four values to illustrate what's going on here. Gas mileage, they gave us a formula. Excel is awesome when it comes to formulas. So the formula for gas mileage is negative 0.0077 times the weight plus 45.556. Okay, I'm going to copy and paste that if I can. Sometimes Firefox doesn't let me copy and paste. See how nice it's being today. Okay, cool. Now this formula, just the way it's written, isn't going to help me with Excel. First of all, Excel isn't going to recognize it as a formula. Can you tell me why? There's no equal sign. Good. Okay, now it recognizes it as a formula, but the problem is it doesn't know what this x is. What is that about? Also, we learned that to do multiplication in Excel, we don't just write a variable next to a number. We write an asterisk. So negative 0.0077 times, this meant times, by the way. I guess if you haven't been in algebra class in a while. When a number and a variable are next to each other, a constant, I should say, and a variable are next to each other, that means we're multiplying. Okay, so we want to multiply negative 0.0077 times the gas mileage. But wait a second, Excel doesn't know that what the heck x is. Okay, we know that x is actually the value in here for weight, A2. Great. So there's our formula. This number they gave us, negative 0.0077 times the weight plus 45.556. Let me see what I get when I hit enter. It should be a number, I don't know, what's a normal gas mileage for a car? Like 35 miles per gallon? It's a small car, so it should be maybe 38 miles per gallon. Let's see what we get. Okay, 30. I was wrong with the math. So it's about 30 miles per gallon if it weighs 2,000 pounds. I wonder if I can use what we did from the last lesson, and I'll scroll down with this formula. Aha! I found the gas mileage for these other cars too. Check it out. Okay, so when the car weighs 2,500 pounds, we plug that value into the formula, and then when we hit enter, or just go to a different, sorry, when I hit enter, lovely. Let me just do this one more time. Okay, and then when it solves that formula, negative point, I'll go up here where it writes the formula out for me up top. Negative 0.0077 times 2,500 plus 45.56 is 26.306. So these values come from plugging the weight into that original formula. Okay, so back to the original problem. That's what this is talking about. It's just giving us a formula to go from weight to miles per gallon on the highway. Let's see if that matches up with our graph that they have here. It looks like it does. 2,000, and I got 30 point something, and that's right here. 2,500, and I got 26 point something. Let's see what we have here. 2,500, yeah, that looks like 26 point something on the graph. Great, okay, so we did the formula correctly.